Maths Aspirants groups organizes online problem solving sessions to help the students, those who prepare for competitive examinations on higher mathematics. Differential equations, in particular ordinary differential equation, is one of the major topic in competitive examinations in the higher fields of mathematics. Few weeks back, we had one session on ordinary differential equations. Some part of it we covered in that session. Today, in continuation with that, we have Dr. Minirani is with us to discuss more on ordinary differential equations. Dr. Minirani is now working as an associate professor at MPSTME NMIMS, deemed to be University, Mumbai. Dr. Minirani took her PhD Institute of Technology, Calicut, and had two post-graduation, one on mathematics from Calicut University and another one oceanography from Cochin University of Science and Technology. Her research interests includes fractal geometry, fixed point theory, oceanography, graph theory, etc. And she is a research guide in her institution. I'm very happy to introduce Dr. Minirani to the students, and I am very thankful to her for being with us on this Sunday. I hope that today's session will be really useful and helpful for the students in their preparations for the competitive examinations. I welcome everyone to this event. Welcome, Minirani.
And good morning, everyone. Let's hope that the session is fruitful for all of you. In the last class or part 1, we have done the first order differential equations, and actually I had briefed you about the theory on first order ordinary differential equations. I told you, see, the solution part is actually easy, but identifying it properly on time, because you have stipulated time in solving each of the problems when you are attempting problems in a competitive exam. So the problem lies in identifying what type of differential equation is it. So this was the last problem that we have attempted. Consider the differential equation sine 2x dy by dx is equal to 2y plus 2 cos x, and y of pi by 4 is given. Then which of the following statements is, or this is an MSQ actually. So we have checked this and we have done this problem. This was the last problem because I have it in my note. This was the last problem that we have done, I think, bounded. We have checked the boundedness. Yeah. So the differential equation given is y minus x into dy by dx is equal to 1. So the condition given here is the solution passes through 0, 0 and alpha 1. We have to find that unknown alpha. This is an MCQ. So let us start doing. So we have dx. So I've written it in the form mdx plus ndy. Sorry. Mdx plus ndy is equal to 0. So you know m is equal to 1. N is equal to x minus y. So this is not an exact differential equation, so you have to find an integrating factor to make it exact. So I think this will work. Dou n by dou x minus dou m by dou y by m. That is actually 1. I can consider this as a function of y. So the integrating factor theory I have explained last time, so I'm not going into the theory. So it is e raised to integral 1 dy with that is equal to e raised to y. So you got the integrating factor. That means I have to multiply. Integrating factor is that term with which when you multiply the differential equation, it becomes exact. So I multiply, this is my differential equation. I multiply this equation. So it's e raised to y dx plus, now it is clear, no? There's no interruption in the sound, right? Is it okay now?
Yes, ma'am. Yes, ma'am, it's
Okay,
clear.
okay. Yeah. Please do tell me because I'm not able to understand. For me, last time it was coming, the vibration, even I could feel it last time, but this time I'm not getting any disturbance as such. So this is my differential equation now. And as per the definition of integrating factor, this has to be an exact differential equation. That is what integrating factor means. Now you know how to solve the an exact differential equation.
Ma'am, please
It's
repeat M
integral.
part.
Yeah. See, anytime you write a differential equation, it has been written as mdx plus ndy is equal to 0. In this form, this is the standard form which I told you to check for exactness. So m is that term which comes with dx, and n is that term or function which comes with dy. So you have to check dou m by dou y and dou n by dou x. If they are equal, then it is exact. And then your solution is integral mdx plus integral ndy. That is only the terms which is not containing x is equal to C as your solution. So first, any time you have to check the
Okay, thank you, ma'am.
anytime you have to check exactness, but you see that it's not equal. So I can say this is not equal, so not exact. Not exact means the next step is to make it exact. That's the only way. And I've given you four ways of finding. So we found that the equation is not exact. So we will find the integrating factor. So I've given you four methods of finding the integrating factor in the last class. So either dou n by dou x minus dou f by dou y by m should be a function of y. Then the integrating factor is e raised to integral fy dy, or else dou m by dou y minus dou n by dou x by n should be a function of x. In that case, e raised to integral fx dx will be an integrating factor. Or else then you have two more different methods. So whenever we come across those problems, then I'll explain. So here I have found that dou n by dou x minus dou m by dou y by m, it's a constant, so you can consider it as a function of y, and so e raised to integral fy dy, that is 1 dy is the integrating factor. So integrating factor means you have to multiply that equation with this factor, so it becomes exact. So you know the solution. Just for this problem, I'm writing the solution of an exact differential equation. Solution is given as integral m dx plus integral n dy. So in that you have to consider only the terms free of x. From n, you have to take only the terms which is free of x, which is equal to c. This will be the solution. So in this is my equation now. So this is my m, this is my n. So from n, you have to take only those terms which does not contain x. So here it will be e raised to y dx plus, in this there is only one term which is not containing that is minus y e raised to y dy. X term you will have to ignore. You have to do integration by parts. First function into integral of second minus derivative of first into integral of second. So you get the solution as e raised to y into x minus y plus 1 is equal to c. You are given a condition here to find it is given that it passes through 0, 0 and alpha 1. So it passes through 0, 0 means you can substitute x equal to 0 and y equal to 0. So you get c is equal to, substituting 0, 0 gives you c is equal to 1. So my solution is so it's given it also passes through alpha 1. This is where you have to find what alpha is. So you get So it is given here. 1 by E is the answer. So again, while finding integrating factors, you can use any of the 4 rules which I have given in the last class, or else you can, by inspection also, sometimes you can find the integrating factor. See, integrating factor for a differential equation is not unique. You can have more than one integrating factors for a given differential equation. Okay. The only condition is you have to give me a function which will, in x and y, which will make that equation exact. That's the only meaning of integrating factor. So you can have more than one integrating factors also. That means if I ask you to give me an integrating factor, you can give me different functions that will make it exact. So next is to find the integrating factor. That's a direct question actually. dy by dx is equal to 2xy square plus y divided by x minus 2y cube. You can use any technique, you can just multiply, but multiplying and checking whether it is exact will definitely take more time. So you can use any of the technique that I've given. So normally we go in the order which I've given, that would be the easiest way. Homogeneous only you can identify, but this is not a homogeneous differential equation. So definitely you have to go to any other 3 methods which I've given you. So write it in mdx plus ndy form. That's the first thing that you can do. That means identify m and n. That's it. So it is x minus 2y cube into dy is equal to 2xy square plus y into dx. I told you the standard form is mdx plus ndy is equal to 0. This is a direct question. Can you do it? Is it an exact differential equation? Definitely it would not have been, because the integrating factor is what is asked. And the options are also given. So definitely it is not. Dou m by dou y and dou n by dou x, anyway you will have to find, because in order to find the integrating factor also you need this expression. But you can see actually when you have to find the integrating factor, the 2 formula that you have is dou m by dou y minus dou n by dou x by n is a function of x, or else the other way, dou n by dou x minus dou m by dou y by m is a function of y. So actually you can see that when you subtract n, just by observing these terms, you will be able to get a hint. So I think this is the same way that we have done last problem. This will help you because you can see m, this is my m. You will get a common term here. So this is nothing but minus 1 minus of this. So it is in minus 4xy divided by your m is y plus 2xy square. You can see there is a common term y coming out. Sorry, this 1. So always observe these expressions and try whether you subtract, you're able to get a common term from here, either x term or y term. So accordingly, you can take the difference. So this has to be a function of y, or else dou m by dou y minus dou n by dou x by n should be a function of x. So both the things you can just observe the terms and find out so that you can do it quickly. So this is a function of y, which is exactly what we want as per that rule. So my integrating factor will be e raised to integral of minus 2 by y dy is equal to minus y raised to minus 2. That's 1 by y square. These are all actually direct questions only. I think the next one is an MSQ. The initial value problem y dash is equal to root y with y of 0 is equal to alpha, alpha greater than or equal to 0 has at least two solutions if alpha is equal to 0, no solution if alpha greater than 0, at least one solution if alpha greater than 0 and a unique solution if alpha is equal to 0. So anyway, first thing is you have to find the solution. Then only you can check all these conditions. Y dash is equal to root y. That means dy by dx is equal to root y. You can write it as this variable separable actually. You have to just integrate both sides. So the solution will be so let us find C first. So we'll check one by one the conditions. When alpha is equal to 0, when alpha is equal to 0, what's happening? C will become 0. So you get this as a solution, or 4y is equal to x square. Y is equal to x square by 4. Can you tell me which are the two answers for this? We have got the solution.
Ma'am, option C and D.
At least one solution if alpha is greater than 0.
Options A and D.
Correct. Options A and C, no? You get two solutions actually when alpha is equal to 0. See, when alpha is equal to 0, yx equal to 0 is also a solution. No? Because it is, see, if you're taking alpha is equal to 0, so y of 0 is 0, no? That is given condition. So this is, so I think A and C is the solution, right? When alpha greater than 0, C is 2 root alpha. think A and C are the solution. Next is a problem on arc length. Do you know the formula for arc length of a given equation y equal to fx
Ma'am,
from A to B?
ma'am,
Root of 1 plus f dash.
Yeah, integral A to B, square
Root
root
of
of 1
1 plus f dash f t.
Correct. This is the formula to find the arc length. Yes.
ma'am, please explain why for alpha equal to 0 we get at least two solutions.
Yeah, see, there are two conditions. No, see, you have see, this is the case. This is the case that you have got 2 root y. This is the solution. 2 root y is equal to x plus c. And you have to solve for c. The given condition is phi of 0 is equal to alpha. So you get your c as 2 root alpha. So you get, this becomes your solution. 2 root y is equal to x plus y of 0 is equal to 0. I'll again give you c is equal to 0. The same solution only, no? Wait. 4y is equal to x squared. So y is equal to x squared by 4. Actually, you're getting only one solution, right? Sorry. So y is equal to x squared by 4 because your c will become 0. So what should be the answer? At least one solution for alpha greater than 0 and a unique solution for alpha is equal to 0, right? Correct.
Yes, ma'am, for
Yeah,
c equal to 0.
yeah, correct. Yes. C is equal to 0, you're going to get the same solution, right? So here you are asked to find the value of L actually. So the next problem is to find the value of L correct up to 3 decimal places. So you have numerical entries also, no, in JAM. One question, this is of that type. So dx by dy is given to you. So here it's just the, your equation is given as dy, instead of dy by dx, it's given as x dash. So that is okay. You can use the same formula and the x, limits has to be given accordingly. That's it. So here the values of y limits are given. So this is the x limits if you will give if you know dy by dx, or else you can use the formula y equal to a to b. This is the other case. So first let's use this formula. The limits are given to you. 1 to 3 root of 1 plus so this is nothing but y square plus 1 the whole square. So this is the answer. You can find it correct to 3 places of decimals because you have to enter the numerical value here. So what's the answer that you're getting? Are you getting the same answer? So this is a problem which is not an MCQ or MSQ. We don't have options to check.
Yes, ma'am, same answer.
Yeah. So you can just find the value of log 3 and then approximate it to 3 places of decimals and then write it. This is again a similar problem. For ABC element of R real numbers, if the differential equation ax square plus bxy plus y square dx plus 2x square plus cxy plus y square dy is equal to 0 is exact, then this is one kind of problem that you can expect always, either for numerical entries or else for MCQs. You have to just use the condition dou m by dou y is equal to dou m by. This is the condition that you have to check. Always write it in the standard form. Don't miss out the negative number. This is where normally mistakes come. M is ax square plus bxy plus y square and n is equal to 2x square plus cxy plus y square.
Answer B, ma'am.
Just equate. B is equal to 4 and C is equal to 2. B is the answer. See, the next question is actually coming. I don't know how it has come and passing through the origin. So how can you enter the equation? So I think it should have been an MCQ, but this options are not there in the question when I've copied down. See, first you need to identify what kind of an equation is it. It is actually Bernoulli's. Bernoulli's means reducible to linear. We have discussed about it in the last class. Also, I told you there is Bernoulli's and Legenders actually coming, which is reducible to linear. So you have exact, see, variable, separable, and homogeneous comes in the first type. After that, you check for exactness. In exactness, if it's not exact, you have 4 ways to find the integrating factor and make it to exact differential equation. In the same way, you have linear differential equations. If you can identify directly, you can write the solution. If not, you have equations which are called Bernoulli's and Legenders actually, which are reducible to linear differential equation. This is one of that kind. So only if you write it in the standard form, you will be able to understand whether it gives you that form. Because just by observing the function as it is given in the question, it may not be easy for you to identify. That's the only problem when you have the problem that you're going to face when you are solving first order ordinary differential equation. When you go to higher order, this problem is not there. There is a proper algorithm by which you can solve the second order or higher order differential equations. There's a step-by-step method. And at each step, you can check whether this condition holds, and then you can go for then you can directly write I can give you shortcuts. But here, shortcuts are there to write the solution. But first, identifying the equation is the first part. If you identify it correctly, then you can directly write the solution. So for this equation, sine y into y by dx is equal to cos y into 1 minus x cos y. So this is nothing but cos y minus x cos square y. So actually, if you put cos y as some variable u, then you will see sin y into dy by dx becomes du by dx. So this will be see, having a constant is not going to create any problem. You can just take it to the other side. So when I go for the substitution, this entire part becomes du by dx actually. Again, it's becoming Bernoulli's only. Or else I can write du by dx is equal to, why I'm writing this in the standard form is so that you can directly write the solution and identify what kind of a differential equation is it. So it is du by dx plus u is equal to x u square. So this is actually Bernoulli's. That means I can just divide by u square and go for another substitution. It becomes a linear differential equation. So I get 1 by u square du by dx plus 1 by u is equal to x. So it is actually, so I can put 1 by u is equal to some v. So it becomes linear in v. That's it. Actually, you have done two substitutions. You have to remember it because you have to come back to the original solution. So it is minus dv by dx plus v is equal to x, or else dv by dx. Now it's linear. So your linear form, if you remember, it is something like this, standard form. dy by dx plus py is equal to q. So here p and q are considered to be functions of x alone. So now this is linear in v. Your p is minus 1 and q is, if I'm going with this equation, so q is minus x. So the solution is, you can directly write the solution once you identify the linear differential equation. So v into an integrating factor. Integrating factor is e raised to integral p dx, e raised to minus x. So v into integrating factor, this is your solution. V into integrating factor is equal to integral q into integrating factor dx. I've given this last time. We have done one problem also, I think. So it is v into e raised to minus x is equal to integral minus x into e raised to minus x dx plus c. And again, integration by parts. C raised to minus x plus e raised to minus x plus. Now you have to go back to v. V is 1 by u. So, and u is cos y. So it is e raised to minus x divided by cos y is equal to x e raised to minus x plus e raised to minus x plus c. I think there is one condition given to find this unknown that's passing through the origin, 0, 0. I of 0 is equal to 0 is given. So if I substitute, I'll get c. Cos 0 is 1. So 1 is equal to 1 plus c. C is equal to 0. So your solution is e raised to minus x by cos y e raised to minus x into x plus 1. C is 0. I can simplify this. E raised to minus x. So you can write sec y is equal to x plus 1. Next problem is also to find the integrating factor. This is again the similar problem. Should we do it? You can give me the answer for this. Finding the integrating factor. Next question. Question number 12. It's given in the standard form. You don't have to worry. Only thing you have to be careful is this, identifying your mn correctly. M is the term that is coming with dx and n is the term that is coming with dy. As per the formula if you are going. And if there is a minus here, you have to consider n as negative of this. These are the common errors that students make. What's the answer? Dou m by dou y is 2x plus 3x square plus 18y. And dou n by dou x y square, no? 2x plus 3x square plus 18y square. I think you can see the when I subtract, no, 2x will go and what remains is this, And you can see this is having a common term with your n. So it has to be dou m by dou y minus dou n by dou xy. That's how I identify. So the difference should have some common term with any of these two. So accordingly, you can decide which one you have to choose. So this becomes 3x square plus 18y square. You know 3 is common there, which will give you the denominator. So that is 3. So you can consider this as a function of x.
X.
Yeah. So your integrating factor is e raised to integral 3 dx. That's nothing but e raised to 3x. See, first order is, for me, I feel like for students also, more time consuming would be first order differential equation compared to higher order differential equation. Because identifying is the first part. You may have to reduce it. If it's not exact, you have to reduce it into exact or linear. Bernoulli's or Legenders means twice the substitution comes. So all those things has to be taken care of. If you don't identify it properly, then it goes wrong. Whereas in higher order, you will not find this much difficulty. Can you tell me what that differential equation is? This one, next one. If you identify it correctly, I think you can do it, because for once you identify, there is a proper step-by-step method of solving differential equations, even if it is first order. You have to identify it.
Bernoulli.
I think this is also Bernoulli's. It looks like Bernoulli's the way it is given. We'll have to just rearrange it and see whether. I think because you have y raised to 5 here, and y raised to 6, it will come here, no? So definitely you can go for a substitution here, so that y raised to 5 dy by dx will become some dv by dx. So that way you can, so suppose I write it in this way, then it becomes easy for you to tell me at least. See, anyway, for Bernoulli's or Legenders, or Legenders is a general case of Bernoulli's only. But see, what you want on the right hand side is, if it's dy by dx, you're considering or trying to make it a linear in y, your other function, which is on the right hand side, should be a function of x. So try to write it as only the function of x on the right hand side, then it will give you some hint to identify what substitution you should make. So here, since y raised to 6 comes here and y raised to 5 dy by dx comes here, that means if I differentiate this, I'm going to get this term. This is what you want for substitution anytime, for Bernoulli's or Legenders or whatever. So you're trying to reduce it into linear. So whatever substitution you make, the new variable that you try to introduce, you're trying to make it linear in that variable. So whatever substitution you make, its derivative should come here. So if I put y raised to 6 is equal to v, I get y raised to 5 dy by dx as dv by dx. So the equation reduces now. So this is dv by dx plus 5 by 6x into v is equal to 5x raised to 4. So now see, this is exactly what you want, no? It's now linear in v. This you can, if you want, don't want this 5 by 6 here, 6 you can take here, okay? Not required. Just for you to make your integrating factor look good compared to. So this is exactly, this is your P and this is your Q. It's linear in V now.
Ma'am, in the previous line, we have to write 1 by 6 dvdx.
Correct. There's a constant coming now. The 6 was there in the question. Yes. 1 by 6 into du by dx. So I forgot that. See, constant is not going to create any problem anyway. So this is what you have. So 1 by 6 I should write. This I forgot actually. So 1 by 6 is coming common. You can take it to the other side. A constant multiple will not create any problem, that you can divide or multiply throughout and get rid of that. Do all those manipulations before you go to the exact formula. So integrating factor is e raised to integral phi by x dx.
X raised to 5.
Correct, x raised to 5. So you can directly write the solution. It's v into integrating factor is equal to integral of q into the integrating factor into q dx plus c. So v into x raised to 5 is equal to 30. It's x raised to 9 coming. So x raised to 10 by 10. So it's 3x raised to 10. So what was v? V was y raised to 6, no? That we have substituted. So y raised to 6, x raised to 5 is equal to 3x raised to 10 plus c. Condition is given, y of 1 is equal to 1. That will give you your c.
C equal to -2.
Correct. C is equal to -2. So I think instead of solving the question would have been, if you have to integrate, so find the value of c. If you have to enter the numerical value. So c is equal to -2 is your answer. This could be, since it's not, the options are not given, I think it comes in your numerical part wherein you have to enter the numerical value. Maybe C would have been asked in this question. So only problem when you have first order differential equation is in identifying it properly. That's it. Once you write it in the standard form, I think you will get a hint of what kind of substitution you have to go into, etc. If y raised to a is an integrating factor of the differential equation, find the value of a. Again, it's a similar problem, finding an integrating factor. We have seen so many problems. In the sense, every year, I should say one question definitely is coming on integrating factor. Because after every 3 or 4 questions, we are getting an integrating factor question. And I think we have solved linear or reducible to linear also in every set of 3 or 4. I think so in every question paper, you can expect one on linear or reducible to linear. That means either Legenders. Legenders, you may have to go for 2 substitutions or Bernoulli's. Bernoulli's is only a special case of Legenders. This is similar problem. You can give me the answer for this. So this is again given in the standard form. If it's given in the standard form, again, it's a little bit simplified for you people. So when you're writing n, don't forget this minus sign.
Ma'am, option B.
Correct. A is equal to. So you're given that this is a different. This is y raised to a is an integrating factor. That means when you multiply by y raised to a, this should become exact. Correct. So if I'm multiplying both by y raised to a, this should become exact. That means this should give you dou m by dou y is equal to dou n by dou x. That means this is a plus 1. This becomes a plus 2 into y raised to a. This should be exact. This is what you have to. Yes. In this case, dou m by dou y, you can equate to dou n by dou x. That's the concept of exactness is only used while you're finding the integrating factor.
Can you explain me, ma'am?
Which one? This one you have to, you want me to explain? Okay, so this is the equation given to you, and the question says y raised to a is an integrating factor. The meaning of saying y raised to a is an integrating factor is if I multiply this equation by y raised to a throughout, it should become an exact differential equation. So you can see if I multiply this throughout by y raised to a, what I'm going to get is 2x y raised to a into y, that is y raised to a plus 1. And then this becomes 3x square into y raised to a. This becomes y raised to a plus 2. So this should be, when I multiply this equation by y raised to a, it has to be an exact differential equation. So your m and n after multiplying with y raised to a is going to be this. This is going to be your m and n after I multiply it by the integrating factor. The meaning is after multiplying with the integrating factor, this has to be exact. That's the property of, or the meaning of integrating factor. That means dou m by dou y should be equal to dou n by dou x. So just equate. So multiply, sorry, find dou m by dou y and dou n by dou x and equate. What is dou m by dou y? Dou m by dou y is a plus 1 into 2x into y raised to a. Correct.
Y.
When I find dou n by dou x, this term becomes 0. So this has to be equal because it's exact. No, you have multiplied with your integrating factor. That means this has to be exact. So you get 2a plus 1 is equal to 6. So a plus 1 is equal to 3, or a is equal to, what did you get? What answer did you give me? 3 minus 1, 2 is not given. No, I made a mistake. Is there a plus or minus mistake that I've made? Yes, there is a minus here now. A is minus 4. Clear? So here it's given general solution. I don't know how it came in JAM. In JAM, do you have answers to write as the entire solution? I don't know. But at least we can discuss what kind of a differential equation it is, because any kind of differential equation of first order can come. Can you tell me whether you can y minus x dy by dx is equal to dy by dx into y square e raised to y? Or else if I simplify, this you can check for exactness. Actually, it is mdx plus mdy it will come. Is it an exact differential equation? Just the way it is written itself, you know. Dou m by dou y cannot be equal to dou n by dou x, right? It's not exact.
Yes, ma'am.
Yeah. So after doing few problems, continuously, you will be able to know, see which sequence you should use in checking the conditions. Or else by observing itself, you will be able to find. What's the solution that you're getting? Your m becomes 1 by y then. You're multiplying by 1 by y square. So, and you have to consider only the terms independent of x. Only this you will consider. So, integral y dy e raised to y. So, there's a minus. What kind of a differential equation is the second one? Dy by dx is equal to x plus 2y plus. This is a standard form. Huh? Standard form. You remember reducible to homogeneous?
Yes, ma'am.
Yeah, this is a standard form. See, once it is given in the standard form, you can just directly go for the substitution. So you have to put x is equal to x plus h and y is equal to y plus k. It's a lengthy problem actually. So you're making this homogeneous by equating these two terms in the bracket as 0. So you have to solve them separately and find h and k. I think you get k is equal to, I've solved it.
3.
Is it 3 or minus 3?
It's minus 3, ma'am.
Minus 3, no? You get h plus 2k is equal to minus 8 and 2h plus k is equal to minus 7. This is the equation that you have to solve. So you get k is equal to minus 3 and h is equal to minus 2. This is only for resubstitution or back substitution that you're finding it and keeping. You're getting dy by dx is equal to x plus 2y by 2x plus y, which is homogeneous. So for homogeneous, there's a standard procedure that you know. You have to put y is equal to vx. So dy by dx becomes v plus x into dv by dx. Product rule. This becomes v plus x into dv by dx is equal to x plus 2vx divided by 2x plus vx. So x goes, this becomes 1 plus 2v by 2 plus v. So x dv by dx you can write as minus v. So 1 plus 2v minus 2v minus v square divided by 2 plus v. So it's 1 minus v square by 2 plus v. Again, homogeneous or reducible to homogeneous, anyway, you are doing the substitution to make it variable separable. So there, that group which comes in the first part actually, the variable separable, then homogeneous, reducible to homogeneous. That means non-homogeneous. Non-homogeneous or homogeneous, you are reducing it into variable separable. Just like if not exact, you are reducing everything to exact. Then you have the third part actually linear and reducible to linear. It's always like that. So variable separable or reducible to variable separable is the first part you can consider. Second part is exact or reducible to exact. And the third you can consider linear or reducible to linear. In order to integrate this, you have to separate this into partial fractions actually. Now you can integrate. First make it in the integrable form. See, this as such is not, and then you can rewrite this also, okay, to integrate. Not necessarily partial fractions. So this you can consider as log C, so that it is easy for you to simplify. I think out of this reducible to linear type and this non-homogeneous, that means reducing to homogeneous part, that this is the lengthier one. And there's no shortcuts also for that. You can simplify this. So after solving, you have to resubstitute, okay? First for V and then for capital X and Y. So you have already found it as your K and H you have already found out that you can substitute. So your solution is x plus y plus 5 by x minus y minus 1 whole cube is equal to C. My God, such a lengthy part. Next problem, consider the differential equation dy by dx is equal to ay minus by square. Can you identify now what kind of differential equation is it?
Bernoulli, ma'am.
Yeah, Bernoulli's. That means reducible to linear, yes. Absolutely. Only when you write it in the standard form, you'll be able to easily identify it. Because I told you, you can, whenever the derivative, that is how you go for substitution. When you have a function here, and its derivative comes together with dy by dx, then you can go for that substitution. So you can actually substitute minus 1 by y or else 1 by y. It's all the same. So this becomes this is now linear. dv by dx plus av is equal to b. So your integrating factor is equal to e raised to ax. So your solution is b into e raised to ax is equal to integral b into e raised to ax dx plus c. So you're given this is nothing but b by a e raised to ax plus c. So you're given y of 0 is equal to y naught, some constant y naught. So you get, what is your b was 1 by y, right? So it is e raised to ax by y. So 1 by y naught is equal to c is equal to 1 by y naught minus b by a. So your solution becomes e raised to ax by y is equal to b by a e raised to ax. In the place of c, you have 1 by y naught minus b by a. So what is the question? Question is, as x tends to infinity, the solution tends to. So as x tends to infinity, what happens to your y? That's the question. to write it as e raised to minus x, otherwise you cannot substitute. What happens to your y? Y will tend to, 1 by y will tend to b by a, right? Or y will tend to a by b. This is MCQ only, not R. It's only state which of the statements is true. Differential equation is linear, differential equation is exact, e raised to x plus y is an integrating factor. Then so many things you have to check. A suitable substitution transform the differential equation into variable separable form. I don't think the differential equation is exact. It's by observing itself. Dou m by dou y and dou n by dou x will not be the same. One is 1 and the other one will come 2. Is it linear? No, it is also not linear. dy by dx if you write. No, you cannot write it. As dy by dx plus py is equal to 2. So a and b is ruled out. E raised to x plus y is an integrating factor of the differential equation is what you have to check. So multiply by e raised to x plus y and see whether dou m by dou y is equal to dou n by dou x. That's the third thing that you can do. E raised to x plus y, your m becomes e raised to x plus y into x plus y plus 1. And n becomes e raised to x plus y into 2x. I don't think that will become so. Will it become equal? Dou m by dou y and dou n by dou x? I don't think. No, it will not. So that's not an integrating factor. It is given an integrating factor. A suitable substitution of the differential equation. Suitable substitution transforms the differential equation to a variable separable. I think that we can try because this x plus y, this is common here, no, x plus y. So this becomes 2 into x plus y. Suppose I substitute some other variable for that. See, this is my differential equation. I think 4 is correct. So x plus y plus 1, it has to be because first 3 is anyway ruled out. So 4 has to be correct. Even otherwise, you see 2x plus 2y plus 1. You can see this term here having a common factor. So I think that substitution should work. So if I put this as z, so dy by dx is equal to dz by dx. Sorry, I made a mistake. 1 plus dy by dx is equal to dz by dx. It's coming now. Yes. This becomes variable separable. So D is correct. If k is a constant such that xy plus k is equal to e raised to x minus 1 the whole square by 2, satisfies the differential equation x dy by dx is equal to x square minus x into y plus x minus 1, then k is. That means this is a solution. Xy plus k is equal to e raised to x minus 1 the whole square by 2 is a solution for the given differential equation. You have to find k. So let us differentiate this and then equate both.
k equal to 1.
Correct, k equal to. From here I get y is equal to you have to just compare also. The differential equation representing the family of circles touching the y-axis at the origin. What's the answer? I have not checked this actually. See, I think they're talking about orthogonal trajectories. Representing the family of circles touching the y-axis at the origin. We have to just write the general equation and it's form the differential equation. I think they are asking about this family of circles touching the y-axis at the origin. No, this is touching the x-axis. It's the other way. Something like this. Some a. The equation of this this is x minus a the whole square plus y square is equal to a square. This is the family of circles. X square minus 2x plus a square plus y square is equal to a square. So x square plus y square minus 2x is equal to 0. So differentiate. 2x plus 2y into dy by dx minus 2a is equal to 0. So 2x plus 2y into dy by dx. You have to eliminate a, right? So what is a? From here you can get a. A is x square plus y square by 2x. What kind of a differential equation is it? The order is first order. It's first order only. Is it linear or linear? Is it linear or non-linear?
Non-linear, ma'am.
Non-linear. Correct. First order non-linear. So write the standard form and then differentiate and eliminate the constants there. We'll get the differential equation. Oh, this is your numerical, I think. You have to find y naught, right? Dy by dx minus y is equal to 1 minus e raised to minus x. It's a linear differential equation. Straight away, it's given in the form only. Dy by dx plus py is equal to q form. So this is a numerical type problem wherein you have to find the limited case as x tends to infinity. So you have to find the solution. Solution, it's easy because it's directly given. It's a linear difference. See, once it is exact or linear directly or variable separable. So those are the three types which has directly a direct formula to solve and get the equation. So your integrating factor will be e raised to minus x, correct? So it is y into e raised to minus x is equal to integral e raised to minus x into 1 minus e raised to minus x dx plus c is your solution. So it's y e raised to minus x is equal to e raised to minus x minus e raised to minus 2x dx. So I can multiply throughout by e raised to x. So this becomes y is equal to I think some condition is given, no? Y of 0 is equal to y naught, some constant. So y naught is equal to half minus 1 plus c. You have terms e raised to x and e raised to minus x. It's given that it's finite, right? This is finite as x tends to infinity. So given limit x tends to infinity, y is finite. So if it has to be finite, this has to be 0, right? There's no other way. That implies y naught plus half should be 0. Or y naught is equal to minus half. There's no other way. As you have both e raised to minus x and e raised to x coming. So that term involving e raised to x has to be 0. That is y naught plus half. So y naught is equal to minus half. This is a numerical question wherein you have to enter the value of y naught. See, again an integrating factor question has come. Integrating factor of x dy by dx plus 3x plus 1y. That is a linear differential equation, okay? Not see, linear differential equation also you are reducing to exact and then solving. Yeah. So if you just rewrite and find out what p is, then that this is also a direct question. So this is my equation, x into dy by dx plus 3x plus 1 into dy by dx is equal to x into e raised to minus 2x. Dy by dx plus 3x plus 1 means 3 plus 1 by x dx. Sorry. What did I do? So your p is 3 plus 1 by x. So your integrating factor for the linear differential equation, this is linear. Integrating factor is e raised to integral p dx. It's equal to e raised to integral 3 plus 1 by x dx. It's equal to e raised to 3x plus log x. So I can write this as e raised to 3x into e raised to log x. That's x. So x e raised to 3x. X e raised to 3x is your integrating factor. So once it is linear, actually, whenever it's linear also, you are finding the integrating factor and making it exact and then writing the solution. But instead, we are directly having a formula of y into integrating factor is integral of q into integrating factor ex plus c. That's actually derived from your original equation only. This is yx be the solution of a differential equation x raised to 4 dy by dx plus 4x cubed y plus sin x is equal to 0 and y of pi is equal to 1. For x positive, then y of pi by 2. Again, you have to find the solution. I think this is also a linear differential equation. I'm seeing only one y there. Rest all are functions of x. You can divide throughout by x raised to 4. It's linear only. It's also direct linear. See, direct linear and direct exact and all, it's very easy. X raised to 4 dy by dx plus 4x cubed y equal to minus sin x. I can write if I want it in the standard form. So it is dy by dx plus 4 by x into y. So it's of the form dy by dx plus py is equal to q, exactly linear only. So your integrating factor is e raised to integral 4 by x dx. It's nothing but x raised to 4. So your solution is y into x raised to 4 is equal to integral of x raised to 4 into minus sin x by x raised to 4 dx plus c. So this is cos x.
Cos x plus c.
Correct. Y into x raised to 4 is equal to cos x plus c, and it's c you have to find out. Y pi is given. So pi raised to 4 is equal to cos pi is minus 1 plus c. So c is equal to pi raised to 4 plus 1. So your y is y into x raised to 4 is equal to y into x raised to 4 is equal to cos x plus pi raised to 4 plus 1. So now you are asked to find y of pi by 2. Right? Yes. So this is pi raised to 4 by 2 raised to 4. Cos pi by 2 is 0.
Option D.
Correct. Option D, no?
Yes, ma'am.
Yeah, option D, correct. 16 into pi raised to 4 plus 1. So this is D. Consider the ordinary difference. This is also linear, no? X dy by dx plus 4y is equal to x0 less than x less than 1. Which of the following? This is an MSQ. Yx is equal to x by 2, yx is equal to x by 2. Which of the following are the solutions to the above? X dy by dx plus 4y. It's also linear only. Integrating factor, just now we have found. Huh? Same integrating factor. None of the options, no?
Yes, ma'am.
How come? It's an error. X cannot take 0 also. 0 to 1. None of the options are coming as solution. Oh, this is a numerical question again. If xt is the solution to differential equation dx by dt is equal to x square t cube plus xt for t greater than 0 satisfying x of 0 is equal to 1, then the value of x root 2, correct to 2 decimal places. That's again a linear differential equation. No. Not linear. So we get dx by dt is equal to x square t cube plus xt. Bernoulli's again. No? V or y. Y is not there. Now we can put y. I made a mistake. It's dx by dt only given, no? So I'll have to multiply the other way. I made a mistake. I have dx by dt here, so I'll have to write 1 by x squared dx by dt. Right, no? What's the solution? It's linear in y now.
E raised to t square.
T square by 2, no? No, the answer you're saying?
No, ma'am.
Yeah. Integrating factor, right?
Yes, ma'am.
Yeah, correct. Y into e raised to t square by 2 is equal to integral. I think you will have to go for substitution. Y dy by dt, correct. So you can write as minus you can put the y square as t. In order to integrate this, I can put t square by 2 is equal to some a. So t dt becomes, so this will become integral. There is minus, there is no minus, no, it's plus. So the integral is minus 2 into a is t square by 2. T square by 2 e raised to t square by 2. So I can write it as common term. No? Is this your integral? So I can write this as y is equal to minus 2 So y is what you have substituted. What was y? Y was 1 by x, right? Yes. What's the answer that is coming? Oh, it's the value of root 2. You have to put t is equal to root 2. X of root 2 is your question. So put t is equal to root 2 and solve.
C raised to minus 1.
C raised to e power minus 1.
Becomes e raised to minus 2, right?
Ma'am, isn't it 1 minus 1?
This becomes, correct, 2 by 2 is 1. Correct.
correct. 1 minus 1 0, so this goes away.
C into e power minus 1, ma'am.
Ma'am, C
Y2
into
is 1 only. Correct. Correct. This is also minus 1. C is given, no? Oh, sorry, C you can find, no? X of 0 is equal to 1 is given. So you could have substituted, I didn't see that, sorry. From here you can find what is C coming actually. When you're putting T is equal to 0, you will get X of 0 is equal to 1 when you do. What I'm getting 1 by X is equal to, this becomes 0 minus 1. So it is plus 2 plus C.
ma'am, C is minus 1.
Correct.
Minus 1, ma'am.
C is minus 1 actually. So you're getting this as minus e raised to minus 1. This is minus e. Correct?
Yes, ma'am.
Minus e correct to 2 decimal places means you have to enter the numerical value, okay? The solution of the differential equation dy by dx is equal to y square cos x plus cos y divided by x sin y minus 2y sin x. Then y of pi by 2 is at y by, that means you have to find c also. Let's check. I have a doubt whether it becomes exact or not. So the standard form means you can write it. Dy into x sin y minus 2y sin x minus, or else I can write this the other way so that I don't have a minus and I don't make mistakes. So I have y square cos x plus cos y into dx plus 2y sin x minus x sin y into dy is equal to 0. I think this
Ma'am,
will
minus.
be minus I have adjusted in this, no?
Okay, ma'am.
Yeah. So your m is y square cos x plus cos y, and your n is to y sin x minus x sin y. Just check dou m by dou y and dou n by dou x. I think it should be.
Exact, ma'am, it is.
It's exact, no? It looks like somewhere your derivative will match. Yes. Equal, exact. Then you're done. Once it is exact, it's simple. So the solution is integral m dx. Your m is y square cos x plus cos y dx plus, from here you have to take only those terms which does not contain x. So there is nothing. So you differentiate with respect to, sorry, integrate with respect to x. So it is y square sin x
Minus sin x, ma'am.
integral of cos is plus sin.
Okay, ma'am. Okay.
Yeah, derivative of cos is minus. Just differentiate and see whether you, anytime you integrate, always do a cross check whenever you have sine and cos. Just differentiate and see whether you're getting the same function. That's it. So I differentiate this, I should get this. That's it. And y of pi by 2 is equal to 0 is given, so you can find your c also. So y is equal to 0, then cos pi by 2 is equal to 0. C is 0, right?
Yes, ma'am.
So y square sin x plus x cos y. Is it coming anywhere in the solution, or else I made a mistake while writing the answer? Y square sin x plus x cos y is equal to pi by 2 is coming here, no? This has to be 0, I think. Maybe I have made a mistake while writing the options.
Ma'am, isn't C pi by 2?
C is coming pi by 2?
Yes, ma'am.
Cos pi by 2 is 0, no?
Cos 0 is 1 and x is pi by 2. The first term cancels and the second term cancels pi by 2.
You have to put x is equal to pi by 2, right? Y
Yeah.
is 0. Correct. X is equal to 0. So your first part becomes 0 plus this becomes pi by 2 into cos of 0. Cos 0 is 1. Correct. Absolutely. So B is the answer. Y square sin x plus x cos y. The solution of the differential equation dy by dx is equal to minus x into x square plus y square minus 10 by y into x square plus y square plus 5, where y0 is equal to 1. Yes. I think this also will come exact. Just check, yeah? I have a doubt because yes, 2xy will come, I think, derivative. Dou m by dou y and dou n by dou x, I think 2xy should come. But is there an extra minus or something coming which is not making it 0? No, I think. And it's polynomial, it's easy. Polynomial integration is also easy. So you get x into x square. So I'll just write it. X cube plus xy square minus 10x into dx plus x square. I think this is exact because you will get 2xy, I think. The other term is independent, no? Am I correct? I think it has to come exact.
Yes, ma'am.
Yeah, because 2xy both are plus. No, I had a doubt whether one is coming negative. In that case, it should have been different. No, this is 2xy. Dou m is
Exact, ma'am.
exact. Correct. Dou m by dou y and dou n by dou x both are 2xy. So exact. Exact means it's done. So your solution is x raised to 4 by 4 plus x square y square by 2 minus 5x square. From here you have to take only the terms which is independent of, so that is y raised to 4 by 4 plus 5y square by is equal to c. Given a condition y of 0 is equal to 1. So 0, 0, 0, 1 by 4. C is 11 by 2, no? No, 11 by 4.
Option D, ma'am.
Answer is D, correct. X raised to 4, yes. 2x square y square plus y raised to 4. 5 4 yes, 20 minus 20x. Oh, this is all plus or minus difference only. You have to be very careful. Minus less. B is the correct answer. Find the continuous solution. But how come this kind of problems comes or what in your jam? When you have to write the answer, only numerical values you will write, no? What are the three kinds of problems that comes in a JAM? One is MCQ, one is MSQ, and the other one is
Only
right,
numerical
only
answer type.
numerical answers is expected, no? Otherwise, how do you type it?
Yes, yes.
Let yx be the continuous solution of the differential equation dy by dx plus y is equal to fx for x greater than or equal to 0, where fx is 2 in the interval 0 to 1 and 0 for x greater than or equal to 1. Then yx is, it's given two parts, fx. So you have dy by dx plus y is equal to 2. And dy by dx plus y is equal to 0 in the two intervals, 0 to 1 and 1 to infinity. So these are the two differential equations you have to solve. One is the case for 0 less than or equal to x less than 1, dy by dx plus y is equal to 2. And for x greater than or equal to 1, dy by dx plus y is equal to 0. So anyway, it is linear only. No, variable separable, no? It's variable separable. It's easy. dy by dx is equal to 2 minus y is what you get. We're given a condition, y of 0 is equal to 0, yes. So your solution in the first interval is 2 minus 2 e raised to minus x in the interval 0 to 1. Now in the second case, it is dy by dx is equal to minus y for x greater than or equal to 0. It's variable separable only. So it is log of y is equal to minus x plus c. So here what you have got from there, you can get a condition in the boundary condition. No, 1, 2. So what is y of 1 here? Should match. No, it's continuous, it is given. It's a continuous solution they have given. So it should match at the boundary 1. So y of 1 here is 2 minus 2 e raised to minus 1. So that you can use here to find c. This has to match with this. So here from this equation, y of 1 is c e raised to minus 1. So this should be same as your value here also. So that's why it is given continuous 2 minus 2 e raised to minus 1. So your C is 2 into e minus 1. So you get your solution as 2 into e minus 1 into e raised to minus x. So this is my solution in the interval x greater than or equal to 1. And my solution in the interval 0 to 1 is this. So is there any option given there? 2 into 1 minus e raised to minus x in the first interval and 2 into e raised to minus, yes. A, option A, no? Option A. So always check the second condition is not given, only one condition, initial condition is given to you, y of 0. So at 1 you can equate it to find the value of C. Okay, got it?
Yes, ma'am.
Yeah. So I think first order is done. What's the time?
Yeah, it's almost towards the
First
end of.
order is completely done with the set of questions which I had for first order, all the previous jam. See, one more
I
question is
think.
there that will complete.
Okay.
The solutions of differential equation dy by dx is equal to sine 2x y raised to 1 by 3 satisfying y of 0 is equal to 0. This is an MSQ, I think, is or R is given. Yes. How do I do that? Y raised to minus 1 by 3, that's variable separable only, no? It's an easy question. So it is y raised to minus 1 by 3 dy is equal to sine 2x dx. It's only to integrate and solve. So it is y raised to 2 by 3 by 2 by 3 is equal to minus cos 2x by x. Sorry, by 2. You're given a condition y of 0 is equal to 0. So it is y raised to 2 by 3 to 3 by 2 is equal to. So you get here 0 is equal to minus half plus c is equal to half, you'll get, no? One minus cos 2x you get here. 1 minus cos 2x by 2 sine square. So sine square. Eight by 27 sine. Is there an answer there? So y value you want? Okay, plus or minus. Sine cube x. Yes. I think the answer is there. Plus
B
or
and
minus
C.
both of, yes, the answer is there.
So thank you, Dr. Minirani, for this session on ordinary differential equations. Students, please note that this session problems from the area of ordinary differential equations. Okay, many people find it scared while saying the question itself because there will be very complicated expressions in the questions and that. So a close acquaintance with the problems and different types of problems is very much needed. Then only you can successfully crack the questions in your exams. And also you should be very aware about the various types of the questions and the different ways to attack the problem. See, sometimes an equation of one kind can be solvable only if you proceed in a particular way. Otherwise, you may be never get any solution and your time will be wasted. So that point is to be very, you have to take care of it, very important point. So now let us have a let's go for an interactive session. You can ask your questions or you can make your comments. Is
In differential equations, cracking the question is actually depending upon identifying the type. See, once you identify the type, and one equation can be solved in 2 different ways or 3 different ways also, because sometimes linear itself may be linear. If you see, like, yeah, you can crack it in another homogeneous, you can crack it in 2 ways. So whichever is easier,
that
you
is
can.
in some problems it may be the case,
Yeah.
but
So in some case, you have to identify it properly, otherwise you cannot solve it.
yeah. And also in an examination point of view, the time is very limited, so you
Yes.
can't you
You
can't spare
cannot do
much
trial
time.
and error there. Yes.
Yeah. Yes, students, please come forward to interaction. For the interaction, you can switch on your video and introduce you first. And yes,
I think students are less in number, right?
yeah, many of them have, I think, disjoined maybe due to network error or I don't know what exactly. But in the beginning, there were around 60 students were there.
Okay.
Is
Hello,
Dia?
ma'am.
Yeah, yes, Adra. Yes.
Ma'am, my name is Adya. I'm a third year BSc student from Kerala. Ma'am, your class was very helpful. It was very much informative, and we got to practice a lot of questions there. It was very much useful. Thank you, ma'am, for this wonderful session.
Thank you, Adra. Adra is from Arts College, Calicut.
Okay, Calicut, Government Arts College. Okay, I'm also from Calicut only, even though I am settled in Mumbai.
Yes, Dia.
Hello, ma'am. Ma'am, I am Dia from West Bengal. I am in IIT Bhubaneswar and I am in MSc first year. Thank you, ma'am. And we got to practice a lot of problems, and it really helps to revise the all the concepts. To do more problems will always help to understand a subject better. Thank you, ma'am.
Dia, you were interactive throughout. I appreciate it.
Thank you, ma'am. Actually, I have a question in the last question,
Yeah.
ma'am. Ma'am, can we also also consider option A as true? Because if yx is 0 for all x, then it is true.
Wait, let me see the question. Yx is equal to 0.
Yes, ma'am.
Our solution was yes. Yes, correct.
Okay, ma'am.
That was an MSQ, right? Yeah.
Yes, ma'am. Yes, ma'am.
Okay, thank you, Dia.
Thank you, sir.
Hello, ma'am.
Yes, Siti.
Good afternoon, ma'am. And today's session was very helpful for us. And ma'am, I am from West Bengal, and I am a MSc student. But the concept you tell us, it was very helpful for practicing and revising all the things. Thank you so much, ma'am, for this great session. Thank you, sir.
Thank you, Didi. Lakshmi.
Hello.
Yes.
Good afternoon, ma'am.
Good
Myself
afternoon.
Lakshmi. I am a third year BSc student from Kerala, studying at Bharathanesh's College, Kodamangalam. I really liked your class because already I have attended that first session too, which
Yeah, I
we took
remember.
for a few days. a few days before, and that also I loved very much. And same way, this also I liked really good. It was
But the
very nice.
interaction was less in between. See, I would have loved it the other way when you asked me more questions rather than I solving everything. In between, also very few students interacted. So you can ask questions only whenever you are solving questions with me.
Yes, ma'am.
Otherwise, no doubts will come. No.
Yes, some questions I was attending at that time, and I was checking whether it is right or not while answering that one.
Yeah.
Because I have already started this in my 5th semester. Now I am in 6th semester. I have
Okay.
already completed these portions in our college. It was already completed in our 5th semester itself. So thank you for explaining such questions and expecting more classes from you. Thank you, ma'am, and thank you, sir.
Thank you.
Thank you, Lakshmi. Any others? Yes, others? Feel free to interact.
I think number of students are also less now. No, so many have left.
Yeah. Yes. After all, it is a Sunday.
Yeah.
And also there may be some, colleges are going for a Christmas vacation next week.
Correct.
There may be some internal exams and all that.
Yes.
And also their examinations are also coming in January. Possibly net examination is going to happen January end.
Jan, the net exam is announced, right?
Yeah, gate examination is also in the February.
Feb, no?
So,
Gate is coming in Feb, no?
yeah, February.
Yeah.
So both January, February are
Correct. For these students who are preparing for competitive exams, actually, it is crucial,
Yeah.
these 2 months, no?
Yeah, mainly February. January 29th. January 29th onwards, net examination is announced.
Correct. I saw the
See,
advertisement.
actually, the net examination were always happen in such a way that in January and December, but due to that COVID and all, that schedules were being changed, and
Correct. Everything is delayed this time.
yeah. Now they have announced that in 2022 they will conduct it 3 times, net
3
examination.
times. Yeah, I read that article, this thing notification. Somebody had circulated.
I don't know how it happens, but possibly they will conduct it 3 times as per their announcement.
For students' practice, it is good having more number of exams. No, by the time they complete, they can start 1 year before. No, the students who are.
And the majority of the students didn't got any opportunity in this period of time.
Yes.
Around 1.5 years, there were no exams.
No exams.
Yeah.
Now everything will be offline, no, sir?
Yeah.
Exams,
now,
college, university exams are also happening offline only, no?
Yes. Now almost all the institutions changed into offline mode, but still only for final year students and all that. Even in many IITs itself, they are not entertaining the first years, still continuing in the online mode and only for the.
Maths still it is okay, but some other science subjects wherein labs are required, no? For them, they are actually suffering more.
Yeah, in mathematics also, there is a lot of difference between online and offline mode.
Any time there's a difference that is common for everyone, but I'm saying if the subject is having lab together with that.
Yeah, you're right, but many students didn't get any IIT experience, even though they are studying in IIT, they didn't see in the institute.
That's true. 2 years, no? Those who are in the first year, actually, for them,
and also
they are going to be in the final year in the next academic year.
In online mode, the peer group interactions will also will be very low as compared to the
Definitely. See, you join an institute to take the advantage of the infrastructure there, the facilities there, the team there, no, to interact with the team, rather than the content that we get. It's almost the same. See, the major reason for joining an institute is that, no, to have a good peer group for discussions and also for the faculty and the infrastructure, everything. So that we are going to miss.
Yeah, the students who have got admission in last year for MSc in IITs, they have got only
They've-
one semester,
correct.
only their last semesters in their
Last
institute.
semester left. Yeah, correct. That is true. Very sad, actually.
Yeah, everything has some positive sides and some negative sides. See, for many people, like especially from Kerala students, while they get admission in IIT at the first time, sometimes they may have a difficulty to survive there, all that emotional feelings and all that. Now they can do the things in a secure emotional field from their home and get acquaintance with their styles and patterns and then go. So that
That is
type of
true.
things are also there.
Advantages is that I should say it has bring the world so close. Same, for example, interacting with people. No, now having sessions. Say, for example, I would have never been able to conduct an offline thing. No, if it would have been offline mode. See, people is now uh, almost ready or is now accepting the online things. No, so earlier we never thought of this option.
Yeah,
Or
and
is this?
also in future there will be only hybrid things,
Yeah.
combining both offline and
Definitely,
online both.
definitely. See, yes.
Definitely,
See,
no one
optimal
will
use
be.
of resources, no, optimal use of
Yeah,
resources will
yeah,
always come to this point. And in a way, it
yeah.
is good. So for working people and all, if they have to do something parallelly, this is a great
No,
help.
no one will be ready for taking a session of 2 hour and taking two and
Traveling,
or three.
traveling,
Yeah.
yes, traveling so many hours, correct.
So
And you can take the
so
advantage of good speakers, no, outside whenever you're conducting a conference or anything. Anybody would be ready because they don't have to spend that much of a time, no. But as you said, the interaction that we expect is not happening.
we may have to speak to laptops,
Yes.
not, not by looking at persons. That is the main difference and difficulty.
Yeah.
Okay, thank you, Dr.
Thank you,
Vinod.
sir.
And
Thank you so much
so
for
please
this
do
opportunity to
share.
interact with the students.
Yeah, please do share the notes so we can
Yeah,
share it with
I
them.
will share it with you, sir. Yes.
So, dear participants, wish you all the very best for in your exams. Let us wind up here. Thank you, everyone.
Yeah. All the best for your competitive exams that has been lined up from now. Thank
Thank
you.
you, ma'am. Thank you, sir.